Hi, my name is Duki Islumbab and ang topic na ako discuss karon is conservation of energy in fluids mechanics using Bernoulli's equation. So, Bernoulli's equation can be viewed as the conservation of energy law for flowing fluids. So, we saw that Bernoulli's equation was the result of using the fact that any extra kinetic or potential energy gained by a system of fluid is caused by external work done on a system by another non-viscous fluid. So Bernoulli's principle can be derived from the principle of conservation of energy. This states that in a steady flow, the sum of all forms of energy in fluids along a streamline is the same at all points on that streamline. This requires that the sum of kinetic energy, potential energy, and internal energy remains constant. So, the Bernoulli's equation describes the qualitative behavior flowing fluid that is usually labeled with the terms Bernoulli's effect. This effect causes the lowering of fluid pressure in regions where the flowing velocity is increased. This lowering of pressure is a constriction of flow path makes seems counterintuitive but seems less so when you consider pressure to be energy density. In the high velocity flow through the constriction, kinetic energy must increase at the expense of pressure energy. The dimension of terms in the equation are kinetic energy per unit volume. The equation above assumes that non-conservative force are acting on the fluid. So, mani ang Bernoulli's equation. So, Bernoulli's equation. So, mani ang formula sa Bernoulli's equation. So, natin left side of the pipe, right side of the pipe. So, P stand for pressure energy plus the rho or stand for mass or density times G or stand for gravity times Y or the height or more sa equation sa potential energy or PE equals mass times the gravity times height plus the kinetic energy, which is ang equation sa kinetic energy is 1/2 times rho times V squared. So ang V stand for velocity or KE equals 1/2 times mass times velocity squared. So kay conservation of energy ni sa at these 2 points, so the energy of the left side of the pipe is equal to the right side of the pipe. So ang height naman sa left side of the pipe is the same sa height sa right side of the pipe. So kay pareham sila, pareham ng height sa left side of sa right side. So ako itangtang sa equation ang height, which is ang potential ang itangtang sa equation. If the velocity kuno sa right side of the pipe is magtigagamay sa daw kuno ang left side of the pipe ang iya velocity magtigagamay, while the pressure of the left side of the pipe is magtigagamay sa daw kuno ang sa right side of the pipe magtigagamay sa. If nasa kay given nga area sa imo pipe, so mo ni mo gamiton. So A times velocity, which is ang left side equals the right side, so A times velocity. So for example, may taon mo ang right side of the pipe, so find the pressure of the right side of the pipe. So nakay 5 diri, so mo ni mo left side ug right side. So ang sa left side nakay given nga 128 kilopascal sa left side ug nasa kay velocity or 0.8 meter per second. So nasa kay height niya which is 2 meter. Ang sa left side naman ay sa right side which is nasa ang ipakita nato ang sa right side which is ang pressure 2. So matipita og nasa kay given nga 6.1 meter per seconds, which is ang dito sa right side of the pipe ug nasa kay height sa right side of the pipe nga 4 meter. So ang density sa water or sa fluid which is 1,000 kilogram meter squared ug ang sa G naman ang sa given na daan nga 9.81 meter per second squared. So using Bernoulli's equation, ato na makompute ang pressure energy sa right side of the pipe. So using formula of Bernoulli's equation is which is P1. So ang P1 nato kay namatay 128 kilopascal, ato ni siya i-multiply sa 1,000 para ma-pascal na lang. para ato siya masolve diri. So 128 kilopascal times 2,000, which is 128,000 plus the density of the water, which is 1,000. So times 9.8, the gravity, times 2 the height of the left side, which is ang magawas na kay 19,600. So ang next naman nato ang plus nga ang sa kinetic energy of the left side. So 1/2 times 1,000 times 0.8 squared, which is ang magawas na kay 320. So ang sa right side na sa ato computer, so equals to copy nato ang pressure plus 1,000 times 9.8 times 4, which is 39,200 plus the kinetic of energy of the right side, which is 1/2 times 1,000 times 6.1 squared, which is 18,605. So pagkawan ato na ni multiply kaning tulo, kaning 1,200 1,200 12800 plus 19,600 plus 320, which is ang magawas niya is 147,920. So ang sa right side aton sa liad na sa 39,200 plus 18,605. So ang gawas niya ay 57,805. So bring down, kapihon na nato ang pressure energy. So ato i-transfer sa 57,805 dire para ma-minus. So 147,920 minus 500 ay 57,805. So ang magawas na kay, which is 90,115, which is Pascal pa na siya. So ato na siya i-convert to kilopascal. So ato siya divide. So 90,115 divided by 1,000, which is 90.11 kilopascal or 90 kilopascal. So muna na ito pressure sa right side of the pipe. So kuha na ito pressure sa right side of the pipe, which is 90 kilopascal. So that's all. Thank you.